Hi, this is Mr. Goma, and in this video, we're going to talk about how to calculate molar mass. So, molar mass is the number of grams in 1 mole of a substance. This sounds like something we should be able to calculate, or at least to measure, and in fact, it is. And in fact, it's something that you're familiar with already. It's the same thing, it's the same number as the average atomic mass, at least for an element, it is, but it has different units. So, for example, for sodium, if you look at the box for sodium, Na on the periodic table, you'll see a 22.99. We learned that was the average atomic mass in AMUs, but it's also the molar mass. The units for molar mass are grams per mole, or G divided by MOL. So grams per mole. Now, so if we want to find the molar mass of an element, really straightforward, we just look straight on the periodic table. So molar mass for N, that's nitrogen. Well, let's look on a periodic table. Here's nitrogen. If we zoom in on nitrogen, we'll see the number at the bottom is 14.01. So the molar mass for nitrogen is 14.01 grams per mole. Titanium, let's take a look at that. That's element number 22. So zoom in right there, and we'll see that the molar mass at the very bottom of the square on the periodic table, 47.87, and that's the molar mass for titanium. If you look up xenon, that's a noble gas on the right-hand side of the periodic table, you should get something like this. Okay, so molar mass for elements, really straightforward. Compounds, just one more extra step. So what you need to do for the molar mass for a compound is add up for the molar mass of all the atoms that make up the compounds. So here's how we're going to do that. So for example, for carbon dioxide, CO2, in order to calculate the mass, the molar mass of the whole compound, step one is just to count the number of each atom. And so in carbon dioxide, we have one carbon and two oxygens. Of course, if there's no subscript, that means we've got a one of something. All right. Number two, what's the molar mass of each element? Well, you look it up. Carbon has a molar mass of 12.01 grams per mole. Oxygen is 16.00 grams per mole. Step three, you multiply the number, the counted number of atoms of each element by the mass, the molar mass for that element. So 1 times 12.01 and 2 times 16.00. Well, the results we're going to get when we multiply them together are 12 plus 32. That's going to be 44.01 grams per mole. That's our answer. Okay, let's do one more just to make sure that you guys are all good with this. All right, we got a new one here. It's calcium nitrate, CaNO3, all in parentheses, then a 2. So first thing we got to do is count the number of each atom. Now, remember, the parentheses means the 2 outside the parentheses distributes. So we have 2 nitrates. That means we've got 2 of everything inside the parentheses. Calcium's not inside the parentheses, so we just have 1 of those calciums. But we're going to have 2 nitrogens because 2 times 1 is 2. And there has an implied 1 subscript on the nitrogen. And we're going to have 6 oxygens, and that's because we have 3 oxygens in nitrate and 2 nitrates, so 3 times 2 is 6. The rest of this is going to be exactly straightforward for what we did before. What's the molar mass of each element? Well, 40.08 for calcium, 14.01 for nitrogen, oxygen is 16.00. So multiply the number by the mass. Here we go. 1 times 40.08, 2 times 14.01, and 6 times 16. We're going to get these numbers when we do the math here. And add up all the results. Boom. 164.16 grams per mole. Now, if you're ever showing your work for one of these problems here, you don't have to show everything. What I'm really looking for, we have our box for our final answer, is what's inside this oval here. Essentially the count times the molar mass for the element and your subtotals and then your overall mass. Hope this helps.